Hi, in this video, we are going to continue our course on polynomials and we are going to look at the property about the sum of squares of the coefficients of a polynomial. So I'm going to show you two questions where we apply or basically figure out how to find the sum of squares of coefficients of a polynomial. So the first problem is this: let P2n of x be this polynomial 6x squared plus 5x plus 1 whole power n, and q2n of x is 3x squared plus 7x plus 2 whole power n. We have to prove that the sum of squares of coefficients of p2n of x and q2n of x are equal, right? So how do we find the sum of squares of the coefficients of a polynomial? So the standard process here is, if you have a polynomial p of x, you can multiply it with p of 1 by x, right? And in this product polynomial, you have to find the coefficient of x bar 0. You should check this. It will be AD x bar d plus AD minus 1 x bar d minus 1 till A naught multiplied by AD by x bar d plus AD minus 1 by x bar d minus 1 till A naught. And you multiply these two polynomials and find the coefficient of x power 0 in the product. So that will obviously be this term multiplied by this term. So that will be AD square plus AD minus 1 square and so on till A naught square. So the method is pretty simple. You multiply the given polynomial with itself and with p of 1 by x and find the coefficient of x bar 0 there. So what we do here is we simply apply that method here. So p2n of x was given as 6x squared plus 5x plus 1 whole power n. So p2n of 1 over x will be 6 by x squared plus 5 by x plus 1 whole power n, right? So if I multiply p2n of x into p2n of 1 over x, what I will get is, you can try factorizing this. If you see here, this can be written as 3x plus 1 power n and 2x plus 1 power n. Upon factorizing this, this is what p of 2n of x is. And similarly, when you take 1 more x there, you will get 3 by x plus 1 power n and 2 by x plus 1 power n. Upon simplifying this a little bit, you will get 3x plus 1 power n times 2x plus 1 power n and x plus 3 power n and x plus 2 power n divided by x power 2n. That is the product of p2n of x and p2n of 1 over x. So if I want the sum of squares of the coefficients of p2n of x, I need to find the coefficient of x power 0 in this, right? However, we actually don't have to find the coefficient. All we have to do is prove that the coefficient is same in both p of 2n of x and q of 2n of x. Now q2n of x was given as 3x squared plus 7x plus 2 whole power n. And if you think about it, this is also easily factorizable. And this is 3x plus 1 power n into x plus 2 power n. So when you multiply it with q2n of 1 by x, you will get 3 by x plus 1 power n and 1 by x plus 2 power n. So the product of q2n of x and q2n of 1 over x will actually become the same thing. If you see, it is 3x plus 1 power n, x plus 2 power n. Then from here you will get x plus 3 power n, and from here you will get basically 2x plus 1 power n. And the whole thing is divided by x power 2n. So the coefficient of x power 0 here will be same as the coefficient of x power 0 here, because actually both the expressions are identical, only the order of the factors is different, right? So that was an easy problem where we just learned how to find the sum of squares of the coefficients of a given polynomial, right? Let's look at another problem. Problem 2. It says, assume that for all x not equal to 0, x plus 1 by x plus root over 2 whole power 12 is equal to summation k goes from 0 to 24 ck x power k minus 12. Now we have to find the value of summation k goes from 0 to 24 and minus 1 power k ck square. So we have to find the sum of squares, but there is a minus sign attached. So sometimes it will be negative, sometimes it will be positive, right? This question appeared in the Korean Maths Olympiad 2006. Korean Maths Olympiad second round 2006. So let's see how we tackle this. So for this question, what we will do is think of this expansion and we will use the substitution x goes to minus 1 by x in that. Why? Because that will help us get a conjugate type of expression here. So we'll say when you do that substitution, it becomes minus 1 by x minus x plus root 2 power 12, right? So minus 1 can be taken out common here and minus 1 power 12 is 1. So it is x plus 1 by x minus root 2 power 12. And that should be obviously equal to summation k goes from 0 to 24. Since x is going to minus 1 by x, you can say ck minus 1 power k minus 12 and it is x power, x was going to minus 1 by x, so it is x power minus 1, so it will be x power 12 minus k. So what have I done here? I have taken the initial given expression and here I have put the substitution x goes to minus 1 by x. Why? Because that is giving me a conjugate type of expression. This expression and this expression are very closely related, but with a negative sign, which I will take advantage of now. So what I will do is I will multiply this expression with this expression. Let's do that on the next screen. So we'll multiply x plus 1 by x plus root 2 whole power 12 and we'll multiply x plus 1 by x minus root 2 whole power 12. And that is simplifying as obviously x plus 1 by x whole square minus 2 power 12. And that becomes basically x squared plus 1 by x squared power 12, right? And now what was on the right hand side? The right hand side, this was equal to summation a goes from 0 to 24 ck x power k minus 12 multiplied by summation k goes from 0 to 12 ck minus 1 power k, and it was actually minus 1 power k minus 12 and it was x power 12 minus k, right? So now think about it, minus 1 power k minus 12 is the same thing as minus 1 power k by minus 1 power 12, which is the same thing as minus 1 power k. So I can write this part, instead of writing minus 1 power k minus 12, I'll write it as minus 1 power k. So this is my expression here. Now, what we have to do is notice we have to find minus 1 power k. The question was asking minus 1 power k ck square, right? The powers are reciprocal of each other. So what we have to look for here is the constant term, coefficient of x power 0 in this expansion. Think about it. You should just put k 0 from to 24 some values and see what is coming. So for example, you will get c0 x power, when you put k 0 minus 12, then you get c1 x power minus 11. And this goes on till c24 x power 12. This is the first expansion. And here what am I getting? When you put 0, you get c0 x power 12 When you put 1, you get C1 into minus 1 into x power 11, right? And so on. When you put 24, what do you get? C24 minus 1 power 24 is 1, and this will be x power minus 12, right? So notice, how do I get my C0 square? And I want to get an expression like C0 square minus C1 square plus C2 square, like this, right? That is what I want to calculate. So how do I get that? I need to multiply this with this so that C0 square comes and the powers get cancelled. Then similarly, I need to multiply C1 with this, right? I will get a minus C1 square. So what I'm doing actually is finding the coefficient of x bar 0 in this product, these two multiplied, right? Now that is super easy because you can find it from the other expression. You can find coefficient of x bar 0 from here in this, right? So think about it. Coefficient of x bar 0 in that expansion is simple. It is x bar 4 plus 1 by x square whole power 12. So basically it's x bar 4 plus 1 power 12 by x bar 24. So I need coefficient of x power 0 in the expansion. So basically I need coefficient of x power 24 in the expansion of x power 4 plus 1 power 12, right? So x power 4 plus 1 power 12 can be written as 1 plus x power 4 power 12, which can be written as the expansion of k goes from 0 to 12, 12ck x power 4 power k, right? And for it to be coefficient of 24, k must be equal to 6, right? So what we get, the coefficient is 12c6 basically, right? 12c6 is equal to 924 is coming as our answer for the summation. K goes from 0 to 24 minus 1 power k ck square. So that is the solution for this question. The key step here was to do the transformation x to minus 1 by x. Remember in the previous question when we tried to find the sum of powers of coefficients, sum of squares of coefficient, we did px and we transformed it to p of 1 by x, and then we multiplied px into p of 1 by x, right? The only difference in that question and this Korean Olympiad question was, instead of x going to 1 by x, we have to do x going to minus 1 by x in order to get the negative signs, right? We needed C0 square minus C1 square plus C2 square minus C3 square and stuff like that. If I had to do C0 square plus C1 square, I would have done simply x goes to 1 by x, right? So I hope you understand the technique by which we are finding the sum of squares of coefficients of polynomials. So that's what I wanted to discuss in this short video. We will come back in the next class with problems that will talk about self-reciprocal polynomials and also about roots of reciprocal polynomials. So a couple of concepts coming up in the next video. So stay tuned for that. If you like what we are doing here, please subscribe to the channel, like the video, comment on whether you like the content or not. All of that will help me grow the channel. So your help is absolutely required for me to continue to provide the content. Right? See you next time.